Okay, so at the end of class today, we were looking at this sheet. Okay, and so step one is get graph paper. So I have graph paper. It should also say get a protractor and a ruler. Okay? Then step two says read through the problem and determine the scale to be used. So what I had said in class was let's do these steps doing example one. So I read through the problem and I find out 5 kilometers north 60 degrees east, and the second vector is 2 kilometers west 50 degrees north. Obviously I can't draw a vector that's 5 kilometers long and 2 kilometers long. So I need a scale. I need like 1 centimeter equals 1 kilometer, or 2 centimeters equals 2 kilometers. Make sure your scale is big enough so that you're not working with an itsy bitsy diagram, because if you are, then even if you're off your length by a millimeter, it's going to make a huge difference in your diagram. So here I might say 2 centimeters equals 1 kilometer, or maybe even 3 centimeters equals 1 kilometer. So then you write example one, let's do 2. Let 2 centimeters equal 1 kilometer. Okay, so I have my scale. Then it says locate your XY axis. So take a look at the vectors and the directions involved in the problem so you know which side of your paper to begin on. Now what I mean by that is if you look, the first vector is going north 60 degrees east, so it's going to go up and over. And then the second vector is going to go west, which is left, 50 degrees north, which is up again. So you better start your diagram lower down, because if you don't, you're going to go off the top of your page and you're not going to be very happy with me. Okay, so I would probably start it at least down here. If you're doing 2 centimeters to 1 kilometer, down here is probably far enough. If you're doing bigger scale, then you probably want to start even lower. Okay, so that is number 3. Number 4 says use your protractor, measure out the first angle. So your first angle is north 60 degrees east, and the key here is how do you hold your protractor? The first direction tells you which way to align your protractor. So if it's north or south, you're going to line your protractor up and down, okay? Either this way or this way. Which of these two ways will depend on the next direction. So it's north 60 degrees east, so I line it up and down, and then from the north, I will measure over 60 degrees. If it had been north 60 degrees west, I would have turned it this way, and from the north, I would have gone down 60. Okay, resist the urge to line it up like this and measure from the 90. It'll get too complicated as we go along. So always align with the first direction. So again, if it was north or south, it would be this way. So now if it was like south 60 degrees west, you'd still line it up and down, but you'd measure from the bottom up 60 degrees. And if it was south 60 degrees east, you'd line it this way. If the first direction is west, like in the second one, then your protractor is going to go either horizontal with the bulging part up or horizontal with the bulging part down, depending on if the second one is north or south. Okay? So our first one is north 60 degrees east. So I go over here. I line my protractor up with the little XY axis. Make sure it's perfectly straight. And then from the north, come down 60 degrees and mark a little line. And I cheated because I haven't quite figured out how I'm going to hold the iPad and do this. Okay, so there's my 60 degree mark. And now the next step, step number 5 says, draw with a ruler the first vector to scale. So the first vector is 5 kilometers and my scale is 2 centimeters. So my first vector needs to be 10 centimeters long. Okay, so I'm going to line up. I could line up the 0, but it'll be too hard for me to hold the ruler. So I'm going to line up the 10, and then I'll have to go to the 20. And I might need to shift the iPad to do this. Okay, so let's see. Will it balance? Kind of. Okay, so I'm lining up the 10, and I know you can't see it, but I'm going to the 20. And I can tell right now, I think I'm going to run out of paper. Okay, so here it is. This is my vector. Put an arrowhead on it because a vector is an arrow. label it, what was it, 5 kilometers. Label the angle, it was in here, north, and it was 60 degrees, so put a 60 degree in there, okay? Vector 1. Next step says, at the head of your first vector, create another little XY axis and measure out the angle. So right here, you're going to make a tiny little XY axis. And you're going to take your protractor again, and this time you're going to measure out west 50 degrees north. So you're going to line it up perfectly right here, and then it's going to be west 50 degrees north, right? So from the west, go up 50 degrees north. Once you do that, now you're going to draw this one to scale. So again, take your protractor, and it's 2 kilometers, so it needs to be 4 centimeters, and mine might just fit. Oh, look at that, it does. Okay, so I'm going to just, because my ruler, I'm going to line it up on the 8 and then go to the 4. So again, I need to balance this iPad. Okay, so now you can see I didn't actually need to go all the way out to the dot I made, but that's okay. My vector is 4 centimeters. Its length is 2 kilometers. The angle that I measured was in here. It's 50 degrees. So make sure you label all those things. And then somewhere on this desk, okay, so the next step says, so with a ruler, I drew out the second vector, and then it says continue the process until all the vectors were drawn. So if there was another vector here, I would just do exactly the same thing on this end, and then I would keep going until I've drew all my vectors, but in this case there's only 2. Now, once you've finished drawing them all, it says draw the resultant vector, starting with the tail of the first and ending at the head of the last. So with your ruler, you start where the first one started, and you go to where the last one ended. So you line it up just like that. And again, I'm going to have to balance this so I can draw. Okay, and I'm going to use a different color just so you can see it. So starting where the first one started and ending where the last one ended, the arrowhead goes up here. Okay, so always the resultant is not head to tail. The ones you're adding up, they always go head to tail. But the resultant always starts where the first one started and ends where the last one ends. Okay? So once you've drawn that, that's step 9. Step 10 says measure the resultant's length and the angle from the origin. And then you need to convert the length back into, like with the scale, back into what the real length is. So when I measure this guy, I have 9.7 maybe. 9.7 centimeters, and every 2 centimeters is a kilometer. So 9.7 centimeters divided by 2 would be 4.85. Just going to double check. Oh, you know what? I'm going to change that. It looks more like it's 9.9 centimeters. So 9.9 centimeters, and you don't have to write this down. I'm just writing it down so I can show you. Every 2 centimeters is a kilometer. So take your 9.9 or whatever length you got and divide it by 2. So this vector's length is 4.95 kilometers. Now we also need the angle. So we go down here, and I would probably line it up with the north because that's how we started. So line it up with the north and make sure it's actually lined up right there. And when I read my vector, I get, looks like 35 degrees. So it would be square bracket. What am I measuring off of? North, 35 degrees. And then which way did I turn? East. So the answer to example 1 is 4.95 kilometers north, 35 degrees east. Give me the direction that would get me back to the start. It would be, that's part B, it would be south, 35 degrees west. Just turn it around. Okay, I want you to try example 2 before the next video. Okay.